Hello everybody, operations with scientific notation, here we go. You might have seen scientific notation in science class already. Let's see what happens. Alright, so we got some scientific notation here. You will see something like this on your calculator every once in a while, and I'm going to highlight that letter E there, and this means scientific notation. So what does it mean to be writing a number in scientific notation? Alright, so whenever you have a very long number, let's say a number like this, it gets annoying very quickly to write all those numbers out, and we want to try to minimize this and write this in the least amount of characters as possible, right? So that's what scientific notation will allow us to do. Allow us to take very big numbers and minimize how many characters I'm going to write. All right, so if you notice something else in scientific notation here, it's always going to be a base of 10 here, okay? So something times 10 to the some power, right? So right now, if you just wrote the number 1, so it's 1 times 10 to the 0 power is just 1, right? 10 to the 0 power is 1, 1 times 1 is 1. So we have 1 times 10 to the first power, right? This is, again, I'm going parentheses exponents. I'm still doing PEMDAS, so I'm doing 10 to the first operation, right? Exponents, that's 10, and 10 times 1 is 10. Alright, if you continue down the line, so 1 times 10 to the second power. 10 squared is 100. 100 times 1 is 100. And you can follow this all the way down to 1 times 10 to the third power. 10 to the third is 1,000. 1,000 times 1 is 1,000, and so on. Okay, so, and this will work down to any power, right? So as your exponent gets bigger, your number is obviously getting bigger, and then we can also have negative exponents. So 1 times 10 to the negative 1 is 0.1. So 10 to the negative 1, as we've seen in the last, is 1/10, right? And or 0.1. And 1 times 10 to the negative 2 powers, 1 over 100. So 0.01, so 1/100th. And so on. 1 times 10 to the negative third power equals 0.001, and dot, 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 dot. Okay, and keep going in both directions. Alright, so let's take a look at some of the examples in here. That's a quick little glimpse of scientific notation. So here's some problems in scientific notation, and I'm asking you to write them in standard form. Alright, so first thing I want you to notice is every single of these numbers has one digit and then a decimal place. And then a decimal, right? So it's a single digits, right? It's in the ones place. Right? All these numbers are written in the ones place. So 2 point something, 4 point something, 7 point something, right? That's always scientific notation. You're not going to see double digits in scientific notation. This would be incorrect. So we're not going to do that, right? Everything is in the ones place and then written in scientific notation. So writing this in standard form. So you have 2.834, and I want to get rid of this 10 squared, and again, 10 squared is simply 100, so multiplying this by 100. Right, so multiplying by 10 squared is multiplying by 100, but anytime you multiply by 100, you're just simply moving a decimal over 2 times to the right, and your number here is 283.4. So 283.4 is the same as 2.834 times 10 squared. In a nutshell. Alright, so 4.9 times 10 to the 5th. Alright, so 4.9 times 10 to the 5th. Right? So I'm going to move this decimal over that way 5 times because I'm to the 5th power. So 1, I don't have anything left, so 2, 3, 4, 5, I'm going to stop there. Every single one of these has to be filled in with a 0. That leaves me with about 490,000. Alright, so 4.9 times 10 to the 5th is the same as 490,000. Now 490,000 is not a big number, so writing that in scientific notation might not be, worth it. But when you get to some levels of science and you start thinking about the size of an electron or a neutron or proton, that these things get very, very small. Think about the speed of lightning, things like that. You start using scientific notation. So let's take a look at another one. 7.8 times 10 to the negative first power, so 7.8. Alright, so if I was positive, I was moving to the right. This one's negative, so I'm going to move it to the left. So left 1 power. So 0.78. Again, because 10 to the negative 1 is 1 over 10, or 1 over 10 to the positive 1, which is 1/10, and this is the same thing as multiplying by 1/10 is the same thing as dividing by 10. So when you multiply, you move by a power of 10, you move to the right. When you divide, you move to the power of left. You move to the left. All right. So however you want to look at this. All right. You can also think about it's times the 10 to the negative number. My negative number is negative infinity is going to the left here. So if you want to think about it that way, so this is negative, so it's going left. 1, 2, 3, 4, 5, 6. All right, just watch your decimal places. Right, so 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. And don't forget your leading 0 there. So if you want to write that a little nicer, 0.12, we have 5 zeros there. 1, 2, 3. All right, so writing in standard form, right? This is all standard form. Now let's take a look at another one, and let's write this in scientific notation. So again, it's going to be one decimal place, so 1, 3 point. Right, so it's going to take the first number, and I'm going to add these trailing zeros, these trailing numbers. You don't have to add any trailing zeros there. Okay, that's completely up to you, but just keep in mind, in order for me, if I put my decimal here, I'm going to put that trailing zero there anyway. If my decimal was here, right, that's where it was, now it's here. Well, this is going to be 1, 2, 3, 4. I would have to move this decimal 4 times to the right to get it back. So in order to tell me that, so times 10 to the 4th would bring it back to there. All right, 1.78. Let's look at that one. 1.78. This one's already in scientific notation. I don't need to do anything else to it. 1.78 is just 1.78 times 10 to the 0 power. I don't need to do anything else to that. 0.039. So 0.039. Okay. I need my decimal to be here after the first non-zero number. Okay. So that means in order to get it back to its original location, I would need to move this 2 places to the left. So really this is going to be 3.9 times 10 to the negative 2 power. Because I'm going left, so negative 2. This one I was moving right, so positive 4. 2, we didn't have to do anything. Let's see, 4, we got 7.22. Right, it's going to take the first non-zero number and put the decimal right after it. Alright, so this is coming from, so I'm putting my decimal here. It's coming from, so if I rewrote this, 0.0007. Well, in order for me to get my decimal back to its original location, I'm going to move to the left. So I'm going in a negative direction. And how many? Well, I'm going 1, 2, 3, 4. So I'm going left 4. So really this is 7.22 times 10 to the negative 4th. And that will be my answer, right? So 7.22 times 10 to the negative 4th is the scientific notation of that. Alright, and then our next number here, we got hundred thousands, millions, and billions. So we got 5.6 billion. So here we go. So we got first non-zero number, 0.6. Okay. So my decimal is here. How am I getting? I'm putting my decimal here. How do I get there? Well, I'm moving to the right, so that's 10 to the positive something. Obviously, you don't have to write the positive, so we'll get rid of that. So 1, 2, 3, 4, 5, 6, 7, 8, 9 to the 9th power. So 5.6 to the 9th power would give me this whole number in standard form. Alright, so moving from scientific to standard and standard to scientific. Here's a little practice on some of these. You can do whichever ones you want. I guess we'll do 1 and 2 for practice. We'll do the first one. So 0.0000 whatever. So 6.0 is so this is my first non-zero number. I am putting my decimal here. It is initially here, so I need to go left, so times 10 to the negative, right? That's going to be negative. And I'm moving over 1, 2, 3, 4, 5, 6 numbers, so 10 to the negative 6. Vice versa, 5 is my first non-zero number, so 5.4. So I'm putting my decimal, let me get rid of that. So I'm going to put my decimal right here. It's initially there, so how do I get from here to there? I'm going to go to the right, so times 10 to the positive 1, 2, 3, 4, 5, 6. And positive 6, but excuse me, we're going to get rid of that positive there. We don't need it. Alright, so a couple examples there. Let's see if there's anything else on here. Again, these are standards. Some are in scientific, moving from each one. Okay, just remember if it's negative, moving to the left. If it's positive, moving to the right. No big deal. Alright, so let's get to some fun stuff. What happens when you start multiplying scientific notation? Alright, so not too bad actually. It's actually much easier than you think. Alright. Slightly, couple things we just have to consider, but nothing too crazy. Alright, so first off, you have 1.4 times 10 to the 4th times 7.6 times 10.3. So it's all multiplication. So it doesn't matter how you multiply, right? In what order, it's going to get the same thing. So what I'm going to do is I'm going to group 1.4, 1.7, and 7.6. I'm going to multiply those first. So 1.4 times 7.6, very easily, on my calculator is 10.64. And then I'm going to multiply the 10 to the 4th and 10 to the 3rd, which is, okay, times 10 to the, okay, so my base is 10, so add my exponents and I get 7. Right? So recap from what we just did, 10 to the 4th times 10 to the 3rd, keep your base, and add your exponents, you get 10 to the 7th. So that means I'm going to take this decimal and move it 7 times that way. Alright, well, like I said before, you can't put a double digit in scientific notation. So really this needs to be 1.064, not 10.0, not 10.64. Times 10 to the, well, now I'm no longer moving it 7 units over there. So if I start from here, then I would really have to move it 8 units to get my actual answer, right? So if I move this decimal 7 times over, 1, 2, 3, 4, 5, 6, 7, well, if I put the decimal place here, then I need to do 1, 2, 3, 4, 5, 6, 7, 8 to get to the same spot there. Next example, right? So we got one with multiplication, and now we got one with division. Okay, so same concept, so I'm just going to do 1.2 divided by 4.8, and I get 0.25. And I'm going to write this down here, so I got 10 to the negative 1st divided by 10 to the negative 4th, which really means 10 to the negative 1st minus negative 4th, right? So when I divide, I subtract my exponents. And this gives me 10 to the, well, 2 minus signs become a plus sign, and it's 10 to the 3rd. So times 10 to the 3rd. So that's telling me to move my decimal 3 times that way. Only that this is not in scientific notation, so I'm not going to move my decimal 3 times that way. I need to rewrite this in scientific notation. So one digit, followed, right, one single digit, or a non-zero number, then followed by a decimal. So this is 2.5 times 10 to the, well, I'm telling you to move 3 places from here. Well, if I have to rewrite this to here, then I'm only going to move this not 3 places, but 2 places. And this is going to be 2.5 times 10 squared. And last but not least, scientific notation to an exponent, raised to an exponent. So I'm just going to do this again. Very nice and easy. It's 4 to the 3rd power, 64, times 10 to the, okay, and then multiply those two, and I get negative 6. So that means I'm going to take this decimal that's there, right, so 64, and move it 6 places to the left, if this was in scientific notation. Again, it's not. So 6.4 times 10 to the, well, so I can't keep my decimal there. I have to put my decimal here. So do I need to move it 6 units to the left? I don't. I'm already moving it 1 unit to the left, so I only have 5 units remaining to move to the left. All right, and there's some operations with scientific notation. Hopefully that makes sense. There is another video there on scientific notation as well. There might be some adding and subtracting in that video. If there is, great. If not, don't go crazy. We'll we'll stop it there. All right, guys. See you soon.